Welcome everyone. Now esters can react with amine. Most esters are very reactive and they can react with amines. And before we dig deep into these types of reaction, there are basics that you need to know. That whenever an ester reacts with ammonia, we are going to form and this is called primary amide or amide. Whenever an ester reacts with ammonia, we form primary amide. When you react the same ester with the now primary amine, now react it with primary amine. For example, we are going to form the product we are forming here is a secondary amide or secondary amide. When you react the same ester with secondary amine, we form R so this is tertiary amide. Now, after knowing all that, since both primary amine, ammonia, and secondary amine have nitrogen, and their nitrogen have a lone pair of electron, now the nitrogen in them makes those substances be capable of acting as a nucleophile. they can act as good nucleophile or beta nucleophile. Now, in the first stage, a nucleophile is added to the carbonyl. So I'm going to give you the reaction mechanism. In the first stage, a nucleophile is added to the carbonyl. So I'm having my R bonded to OR prime. So I'm supposed to add a nucleophile to it. So I'm going to have a situation where a reaction is occurring. And in that reaction, I must have a nucleophile. And my nucleophile can be ammonia, primary amine, or secondary amine. But for this matter, let me pick primary amine. So I'm going to have R that is bonded to NH2. So there's a lone pair of electrons on top of N, which is nitrogen. So in step 1, I'm going to have nucleophilic addition. So how am I going to show that? A nucleophile, the lone pair of electrons found on nitrogen, are going to be donated to the carbonyl. What will that one cause? The double bond is going to open up. And remember, oxygen has 2 lone pair of electrons. So when we get that, the substance that we are going to form at the end of the day is R, that is now opened, is bonded to OR prime. Then on the other end, we are having the nucleophile attaching itself. So I'm going to have NH that is bonded to a H on one end and bonded to R on another end. Now, I'm going to treat these as R double prime. Now, then remember the oxygen here, the double bond broke. Now we are going to have 3 lone pairs and a negatively charged on that oxygen. Now, that's step 1 done. What is going to happen in our step 2? In step 2 now, we have to deprotonate the intermediate that we form. Remember, it is having a partial positive charge here. So in the next stage, our substance is going to be deprotonated. So what is going to deprotonate it is just the primary amine we still have. So it is going to be R N H 2. So what is going to happen? The lone pair of electrons found here are going to attack this hydrogen. When that happens, it is going to open up. And when it opens up, the new product I'm going to form here is substance that looks like this, R, that is bonded to OR prime, that is bonded to NH, that is bonded to R double prime. Then I'm having oxygen with its 3 lone pair of electrons and a negative charge. Now remember we said in step 2 what was happening? Step 2, we are having deprotonation reaction. Now, after our substance have been deprotonated, we are going to go to step 3. Now, in our step 3, you're supposed to ask yourself what is really going to happen. Now, we have an intermediate formed, and now you really need to know that we can form a living group here because we form a tetrahedron intermediate. So this substance here is a tetrahedron intermediate. If you look at it keenly, realize that this substance is a tetrahedron intermediate. So it can reorganize itself and expel OR, this one here. So let us see how that is going to happen. Now, a lone pair of electron is going to be brought here to form a double bond, and by that, OR will be expelled out. Now, in the next stage, now we are going to have minus OR, and the product we are going to form is R, that is bonded to NHR, that is having a double bond with oxygen, plus ROH. So what have we formed? We formed a secondary amide. A secondary amide through that reaction mechanism. So we are forming a secondary amide. And there are key things we need to know. The first thing, during this reaction, in order to restore the C double bond O in the carbonyl, alkoxide, our alkoxide, which was RO, the minus charge, or our R, NH minus, must be expelled. And there's something I did not explain. Let me explain it. When we were having this molecule attached to our carbonyl, carbon, and RO also attached, to know which one is being expelled and which one is not, you should look at their pKa. Try to check their pKa. You'll realize that alcohol has a pKa of 16. And amine or amine has a pKa of 38. So for that reason, alkoxy group, the alkoxy group is a weaker base, therefore a better leaving group. So that's why it was expelled, to restore the carbon oxygen double bond in the carbonyl. So I thought you should know that. It will enable you understand the reaction mechanism very well and why YOR was being expelled and NHR is remaining in the solution. Thank you very much and have a wonderful time.